All right, in this lesson we're going to be going over how to make sure you know how to reflect functions either across the x-axis or across the y-axis. So whenever you have a function, we'll just call any function f of x. So we have an absolute value function. It looks like the absolute value function would be known as f of x equals the absolute value of, we'll put x plus 2, because it shifts 2 units to the left and it still goes up 1 and over 1. Now if we want to reflect this across the x-axis, we would simply put a negative. So we would make this f of x. If we want to make that a negative f of x, that would equal negative absolute value of x plus 2. Alright, so all you'd have to do to reflect it across the x-axis is apply a negative on the outside of the whole function. So you'd multiply it, everything, basically all the values go across. So here's an example of that if we want to reflect over the x-axis. So you'll notice I just made up a function and I have different sliders, so it doesn't matter what my a value is. I'm just going to keep my a value 1. Really doesn't matter what my h value is or what my k value is. You'll notice if I type in negative f of x, everything is reflected across this x-axis right here. Whereas the other example is how do we reflect across the y-axis? Well, in order to do that, you have to do f of negative x. So what would that look like? Instead of a positive x, I would make a negative x plus 2. And that would reflect it across the y-axis. So here's an example of that. All right, you'll see how no matter what function I have here, whether the a value is positive or negative, whether I slide it left or right, or whether I slide it up or down, as long as I put f of negative x on the inside of the parentheses, this function is reflected across this y-axis right here. So let's take a look at our problem. All right, and our problem is going to go one of two directions. They're either going to be asking you to reflect it across the x-axis, where you're going to be using this concept, or they're going to be asking you to reflect it across the y-axis, where you're using this concept. So here we go. Problem number 1. It says, this graph is a function of f. Function g is defined as g of x equals f of negative x. So you can clearly see right here they have decided to reflect things across the y-axis. So what we need to do is here's our y-axis, and we need to reflect it across the y-axis. So if we go across the y-axis, what would that look like? So let me go ahead and kind of do a little drawing here as best I can. So if I go across the y-axis, every single point you can see should be reflected across, and that's what the picture is that I'm going to be looking at. So right here, I'm going to just go down here, and I'm looking for one that is reflected across. So if that's at negative 2, this point should be at positive 2, and that's not it. That's not it. There it is right there. It looks like it's answer choice C. All right, let's take a look at the next one. Well, we can clearly see what's happening here. You can clearly see that it is definitely being reflected across the y-axis. So if it is being reflected across the y-axis, what do we have? If we have, there's f of x, and there's g of x. So g of x is going to equal f of negative x. And that's what causes it to reflect it across the y-axis. So that's what I'm going to be looking for. G of x I know is going to equal f of negative x. So g of x equals f of, there it is. Okay. This means they're the same function. This means it reflects it across the x-axis, and this means it reflects it across the y-axis. And this means it reflects across the x-axis and the y-axis. Okay, go ahead and do a couple more real quick. Just do a couple more. Let's do reflecting. See what we come up with. Just random problems. Who knows what we're going to get? Ooh, well, this one looks like it's reflected both places. Like it's reflected across the x-axis and the y-axis. All right, so if I take this function right here, we'll call it f of x. And there's the function right there. So I have f of x equals -2 times absolute value of x plus 3 plus 3. All right, and it looks right here, it looks like it's reflected across the y-axis and the x. Both things are happening right here. So it's definitely going across the y-axis, but it's also definitely going across the x-axis. So there's two things that are happening. So you know what we're going to do? Let's use some Desmos, and we can kind of see how it works. All right. So I'm going to go over here and take a look at Desmos. I'm just going to go ahead and open up so you guys can see how it works. All right. So I'm going to put f of x equals -2. And we're going to go down here and put the absolute value bars and put x plus 3. And I think it was -3. I'm just going to make sure to zoom out. Or was it +3? Oh, maybe it was +3. Let me look real quick. Yeah, it was +3. +3. All right, so if I wanted to just reflect it across the y-axis, here's what I would do. Okay, I'm going to put g of x equals, I'm going to put -2. I'm going to still put the absolute value bar, but this inside here, I'm going to make it a -x plus 3, and then put +3. And now you can see I've reflected it across the y-axis. Well, now if I want to take that again and reflect it across the x-axis, well then here's what I got to do. All right, I got to multiply this whole thing by a negative, which means I got to open up this parentheses and then see how it closes it right here. I close it. So what do I have to do? I got to actually put a negative on the outside of it, and now I've done both reflections. So what would that function actually look like? What does g of x actually equal to? I'm going to do a different function here. It's going to call it h of x. So if I do a negative times a negative, that makes it a positive. And if I put the absolute value, I'm still going to have a -x plus 3 inside of it. But then this negative multiplied to that positive 3 is going to make it a -3. And now you guys can see that these are the exact same. So I'm going to be looking for an answer that looks like this. That's what I'm going to be looking for. All right, so it says, what is the equation of g? So there's two things that happen there. So I'm going to go and do the work right here on the page so you can see how I would do it. So remember, we're dealing with two reflections. So if I take f of x, which is -2 times the absolute value of x plus 3 plus 3, and I want to change it, I know g of x, because we're doing with two reflections, I know I got to take this whole thing and multiply it by a negative, and so that becomes 2 times the absolute value of x plus 3. You're like, it does not, by the way, that negative cannot get into those absolute value bars, so you're safe there. And a negative times a positive is a negative. So that's one of the transformations. So right there I reflected it across the x-axis. Now I have to reflect it across the y-axis, so I got to do one more transformation, and I got to make this x negative. All right. Now, this is the only part that's tricky, because in the answer they put 3 minus x instead of -x plus 3. So this is the answer that I'm looking for. So we got a +2 right there. We've got 3 minus x minus 3. So I'm going to be choosing answer choice D because we're dealing with both reflections. All right. All right. Let's go and do one more here. All right. So on this one, if we take a look at it, it says here we have a graph of a a cubed root function. My apologies. A cubed root function, and there's the cubed root function. And so you can see how it goes. If I am going to do this function, what I need you to understand is If I have a negative right there on the outside, that is being reflected across the x-axis. So I'm going to put, we're trying to reflect across the x-axis. That's what we're trying to do. Because what we're doing is we're taking g of x is going to equal negative f of x, because all they did was apply it. So what I'm looking for is I'm going across the x-axis, so I'm looking for a graph that kind of looks like this and goes up. That's what I'm going to be looking for. A graph that looks like this, which is definitely not A. Totally not A. Oh, I'm liking B. Yep, I'm liking B. Yep, definitely. Totally B. All right, so there's 4 problems. You're going to get some type of problems like that, and that's all you're dealing with. You're either dealing with one or two things, either reflecting across the x-axis where it's negative f of x, no matter what happens, all right, or you're dealing with, oh, wrong one, across the y-axis, which is f of negative x, and that's how you are dealing with reflecting functions. Hope it was helpful.